Hello everyone, myself Maruthi, welcome you all to this physics video session. In this video, I have taken a topic from chemistry, that is ionic bonding. Right, the reason behind or the secret behind why atoms combine. What's the need for them to combine? What's the need? Why they want to behave like someone else when they are having their own character? Right, why they want to behave like someone else? Right, someone else like inert. What's the speciality of them? Yes, those special candidates are zero group elements. The elements belonging to the zero group elements are having outermost orbital completely filled with 8 electrons, octet configuration, ns2 np6 electronic configuration. The remaining all elements of the periodic table, 1a, 2a, 3a, everyone wants to involve in the chemical bonding either by losing the electron or gaining the electron, but everyone wants to try to become inert like the zero group elements. Right, so the process of bonding are varieties. Right, the ways of bonding, right, the bonding between both of two elements may take place by completely transferring. Come on man, I will give it to you, please take it. If we are having an extra, right, if we get rid of that one, it may be 1 electron or 2 electron or 3 electrons. We like to get rid of that and leave it and become like the getting the outermost orbital completely filled with ns2 np6 configuration, or few elements may be there. They want to take electron, they want to gain electron. It may be 1 or 2 or 3, right, gain electrons and make their outermost orbital completely filled. Right, that's the bonding. Right, but today I'm going to discuss about a variety of bonding which is nothing but ionic bond, right, in which complete transfer of electron takes place. They are not going to share. Come on, get rid of, take this from me. So that is nothing but ionic bond. So I'm going to explain ionic bond with the help of magnesium chloride. Right, how magnesium and chlorine combine together. Who is giving electrons and who is taking electrons, right? Let's discuss regarding that one. That's the point says, right? What is this ionic bond? So as I said you, two atoms, right? One atom get rid of electron and becomes positively charged, and one atom take the electrons and becomes negatively charged. Right, one is cation, the other is anion. Right, they are oppositely charged particles. As they are oppositely charged, get attracted, they come close, means there is a type of force in between them. That is nothing but electrostatic force of attraction. Right, the attraction because of electrons, electrovalent electron. That's what he says. The electrostatic force of attraction that helps anion, right? It's nothing but negatively charged particles. Cations are nothing but positively charged particles, right, together to form a newly neutral compounds. Right, the one is positively charged, the other is negatively charged. When they combine, they don't have any charge, they will be neutral. Such a type of new compound is formed, and the bond formed, the type of bond is nothing but ionic bond. That's what the bond says. The electrostatic force of attraction that keeps cations and ions together, making into neutral, new compound, is called ionic bond. Now we are going with an example, that is nothing but magnesium and chlorine combine together form magnesium chloride, mgcl2. Right, how it is forming, how magnesium is transforming itself. Right, directly a magnesium and a chlorine. No. First the magnesium becomes like cation. Right, chlorine becomes like anion. Right. Why? Because magnesium is neutrally charged, chlorine is neutrally charged. It is an atom and it is an atom. Right, when it is just an atom, the charge is neutral. They won't get attracted. Right, first that atom should become ion, either cation or negative anion. Right, after becoming into ions, either cation or anion, some kind of force gets between them. Why? Because oppositely charged. So the first stage is becoming the atom into an ion. How it is forming? Let me explain you. Right, cation formation. So magnesium is transforming itself into magnesium 2 plus, which is positive, which means cation. That's what he says. Cation formation, Mg2 plus. Okay, let's come over there. Now, what is the topic what we are taking? We are taking magnesium. Fine. What is the atomic number of magnesium? Atomic number of magnesium, right? Magnesium atomic number is nothing but 12. right? What does it mean? It means 12 protons are there and 12 electrons are there. And we know all the 12 protons are present exactly in the middle of the atom in the nucleus. They are not going to change. But whereas the electrons gets distributed, right? Few gets into the first orbit. After the first orbit is filled, they get into the second orbit. After the second orbit is filled, they get into the third orbit and so on, basing upon the number of electrons available. Right, here how many electrons are available? 2 electrons are available in magnesium. So how we are distributing? We are distributing 2 electrons in the first orbit, that is nothing but the K. Right, 2 electrons are getting adjusted in the K, right? Later on, 2s2, 2p6, right? 8 electrons are getting adjusted in L orbit, right? And in the third orbit, this is K, this is L, and this is nothing but M, the third orbit. In that third orbit, we are having 2 electrons. 2 electrons are accommodated in the third orbit. So that's what the electronic configuration, 1s2, 2s2, 2p6, and 3s2. Okay, now comes valence electrons. Means how many electrons are present in the outermost orbit. So first orbit, yes, we know we can accommodate 2 electrons in that one. Right, we can accommodate 2 electrons in that one. That's nothing but 2. In the second orbit, we can accommodate 8 electrons. 6 plus 2, 8. Right, in the third orbit, we are making only 2 to sit there. If you want me to write like that, it's nothing but 2, 8, 2. In the first orbit, 2 electrons. Right, in the second orbit, 8 electrons. In the third orbit, only 2 are sitting. But please remember, if the outermost orbit is having 8 electrons in that, then it will be stable. Right, you have to remember, if the outermost orbital is having octet configuration, 8 electron configuration, then it will be stable. Fine. Now, but outermost orbit, how many it is having? Only 2 electrons. So, it is not stable. It wants to become stable like nearby inerts. Right? Whoever is nearby inert, he likes to become like that. That's what I said. Few elements wants to become like someone else. Someone else is nothing but inert gases. Right. Now, for magnesium, whose atomic number is 10, the nearby inert is neon. Nearby unit is neon. Why? Because neon atomic number is 10. Right? So, neon, right, if you go for inert gas electronic configuration, magnesium is nothing but neon 3s2. It means it is filled till neon, right, till second orbit. Now, in the third orbit, 2 more electrons are there. By this, we can say that the valence electron, that means electrons present in the outermost orbital, are nothing but 2. Right? But it doesn't want 2, it wants 8. If 8 are there in the outermost, then it will be stable. Then what's its plan? So in the outermost orbit, how many are there? 2. It can't gain 6 more. 2 can't become 8. If it requires, it wants to become 8, it has to get 6 more, which is not at all possible. Only tetravalency is possible. It can make it, in maximum it can bring only 4. But here it is requiring 6, so there is no alternative for that one. So what it does, it likes to lose those 2 electrons. I want to get rid of those 2. I like to get rid of those 2 so that I will be having 2, 8 only. Only first orbit and second orbit are filled. Means it behaves like it wants to, it tries to. Right, that's what he said. So, outermost orbital valence electrons are 2. Fine. But please remember, we are talking about magnesium atom. Right, 12 protons, 12 electrons, therefore equal number of electrons and equal number of protons, therefore it is neutral. Fine. Now the symbol of magnesium is nothing but Mg, but if you want me to draw Lewis dot picture of magnesium, I can draw it as magnesium. Right, and how many electrons, how many valence electrons are there? 2. Therefore we can go with a dot. Yes, that is the Lewis dot picture of magnesium. Now, this is the situation of magnesium atom. Right? Atom is neutral, but it is not stable. Why? Because outermost orbital is not filled with 8s. So what I said, right, it likes to lose 2 electrons. It likes to get rid of the 2 electrons present in the outermost orbit. So these are removed. Right. So that's what he says. Outermost orbit is not completely filled. It is not having 8 electrons. So it likes to lose 2 electrons. That's what. Lose electron to get octet configuration. Like it will lose 2 electrons. If it loses 2 electrons, let me go with this one. If it loses 2 electrons, what does it become? It becomes 2, 8. Right. If it is 2, 8, shall I say it is straight away it is not magnesium. It is behaving like neon. How? Because it is having 10 electrons. 10 electrons means it's nothing but it is behaving like neon. Okay. So if out of course, please remember, though we lose electrons, number of protons doesn't change. Therefore, atomic number of that one is still 12 itself. Right? The electrons which are present in the outermost orbit are removed. So, electronic configuration I can straight away call it as neon. Now, for neon, how many valence electrons are there? Outermost orbit is having 8 electrons. Fine. Now let us check it out. How many electrons it has? 10. How many protons it has? 12. Are they both equal? No. If they are not equal, it is no more an atom. Right. It is an ion. Who is more? Electrons are 10. Why? Because it lost 2 electrons from the outermost orbit. Protons are 12. So which are more? Protons are more. How many more? 2 more. Right? Therefore, it is not a neutral. It is a positively charged particle. It's a positively charged. Okay. But how many? How many more? 2 plus. It is dipositive. We can call it as dipositive also. We can call it as dipositive. And the charge is as if it is nothing but, if we have to write it as Mg, but if you write just Mg, it is nothing but atom. Now it is not Mg, it is not neutral. Mg2 plus ion. Mg2 plus ion. So as it is having positive ion, we call it as cation. So this is how a magnesium atom has converted into magnesium ion, which is positive. Therefore, it is a magnesium cation. So just remember, does it lose or gain? It lost 2 electrons. That's what we represent like the symbolical magnesium atom, right? Lost 2 electrons and became magnesium 2 plus ion, dipositive cation. Whereas magnesium 12, right, it is nothing but neutral atom. So this is the process of formation of magnesium atom to magnesium dipositive ion, formation of cation. Of course, get ready for magnesium chloride. Yeah, let's come back to the formation of anion now. So earlier we were discussing about cation Mg2 plus. Now I'm going to explain you regarding anion Cl2 minus. Right, how it was going on? I think it's Cl minus. Let's work on that one. So anion, it is nothing but negative ion. So how it is going on? Let's discuss here. Now we are talking about the formation of Cl minus, right? Chlorine negative ion. Now atomic number of chlorine, as we all know, it's nothing but 17. Fine. Now if you go for the electronic configuration of that one, if you distribute it 1s2, 2s2, 2p6, 3s2, 3p5, right? Means in the first orbit, which is nothing but the K, it is having 2 electrons. Fine, right? It's nothing but 2 electrons. In the second orbit, which is nothing but L, it is having 8 electrons. I'm happy with that. Now, in the third orbit, which is nothing but this is K, N, and L, and M, it is having 7 electrons. Fine, 2, 8, 7. Right. So when we are checking it out, first orbit, as we all know, we can accommodate 2 electrons only. Fine. In the second orbit, we are done. We can accommodate only 8. Fine. Means if second orbit is filled, means what? Till neon we have completed that 2, 8. Right. In the third orbit, totally 7 are there. But we know third orbit can be accommodated with 8 electrons. Fine. But how many are sitting there? 3s2, 3p6, 3p5. So totally how many? 2 plus 5. It's nothing but 7. Means the outermost orbit, which is nothing but K and M, it is having 7 electrons. Means the valence electrons in chlorine is nothing but 7. That is what? That's what I said. In bonding, valence electron plays an important role. Basing upon the valence electron, the type of bonding. But the need of bonding arises because of the valence electron. That's what the point says. Now the valence electrons of chlorine is nothing but 7. Fine. But we are talking about chlorine atom. Atom means equal number of electrons and equal number of protons. There is no, still now we didn't do yet. So it is a neutral atom, equal number of electrons and equal number of protons. 17 means 17 protons. We count only the protons for atomic number. So how many electrons are there? It's nothing but 17. Therefore it is nothing but neutral. Fine. Now that's what the symbol says here. But if you like to know, the Lewis dot picture of chlorine, we can go like this. Chlorine, right? How many valence electrons are there? 7. So 1 on the top, 2 on the here, 3 and 4. I didn't straight away go 2 at a place. You have to remember, this is a Lewis dot picture of chlorine. Right. So now 4 we have already done. We are left over with 3 more. I started pairing the dots. Yes, see here, it is left over with 1 electron. The valence electrons are only 7. So this is Lewis dot picture of chlorine. We all know 17 protons and the inner electrons, all these inner, and the 17 is represented by the chlorine, which is nothing but the kernel. According to Lewis, the inner orbits and the nucleus is represented by the symbol, which we call it as kernel. The valence electrons are represented with the dots. So everything story is in the Lewis dot picture. Fine? Right, of course, right. It's nothing but as it is a neutral one, the symbol is Cl. Fine. So what's the need now? What's the process going on? But as you all know, as the outer electrons are 7, right? If it is 8, it will be completely filled. That's what. So as it is having 7, what we can say, that outermost orbit is not completely filled. It is not having octet, or it is not having ns2 and p6 electronic configuration, which is needed for stability. Means chlorine atom is not stable. Reason, outermost orbit is not completely filled. If it has to be filled, it should have 8 electrons, right? So what does it do, right? Is it going to get rid of that 7? Is it possible? No. Maximum, it can go with only 4. Right, but here, it is having 7. What shall it do? The best thing is, the easiest way is, get 1 electron, gain 1 electron from someone. Someone who is ready to leave, someone who is ready to give. It might be anyone. Right. But it has to gain 1 electron. Yeah. So, what is the need for the chlorine atom means? To get stability, it likes to gain 1 electron. Where? In the outermost orbit. Right? If it gains 1 electron, the outermost orbit is becoming 8. Valence electrons are becoming 8. Right? Therefore, it will become stable. Okay, so then what will be the electronic configuration? So, if it goes for the inert gas electronic configuration, it is nothing but N2, neon, and it's nothing but 3s2 and 3p6. Okay, neon means second orbit is completely filled. Now third orbit is also completely filled. If its second orbit is filled and third orbit is filled, indirectly we can say it is filled till argon. Yes. So, our chlorine now behaving like argon. That's what I said. Few atoms either lose or gain, try to behave like someone else. So, here chlorine atom is trying to behave like the nearby unit. Who is nearby unit to chlorine? 18 wala. It's nothing but argon. So, now it is behaving. If it gains 1 electron, it is ready to become, it will become inert like argon. Now, if you go for the electronic configuration, it's cool there. So, it's nothing but 1s2, right? It's nothing but 2s2. It's 2p6, right? 3s2 and 3p6. Fine. But please remember, protons never change. It will be fixed. It will be 17 only. Right. So what we got? Protons are 17. Electrons are 18. Valence electrons are 8, right? So do you think they both are having same number of electrons and protons? No, right? It is not an atom. Why? Because it is not having equal. So who is more? Electrons are more. Why? Because electrons are 18, protons are 17. One more, right? So it is not neutral. It is negatively charged. And it is Cl minus, uni-negative anion. Uni, but because only one more, 1 electron more. So chlorine atom became chlorine ion. Right, chlorine ion, Ue positive ion. Is it clear? That's what I am showing with the Pelpa picture here. Chlorine gained one electron and became chlorine ion. Chlorine gained one electron and became chlorine ion. Chlorine is neutral atom, right? So it's chlorine is neutral atom, right? Gained electron and became negative ion, which is nothing but anion. Is it clear? Now what it says, chlorine gains one electron and becomes chlorine Cl minus ion. This is when going on. So what we are ready with now? We are ready with chlorine anion. Earlier we are ready with magnesium cation. So formation of cation and formation of anion. What next? The electrostatic force of attraction between the oppositely charged particles. Magnesium 2 plus is cation, positively charged. Cl minus is anion, negatively charged. Opposite charges attract with each other, right? So they come close. After coming close, they get bonded. Then there is a type of force which is holding them together. That is nothing but electrostatic force of attraction. But if you check it out, magnesium has lost 2 electrons. Fine. But chlorine has gained only 1 electron. What about the remaining? What about the remaining? Yes, you are right. One more chlorine atom takes one with the electron sent by magnesium. Magnesium is giving 2 electrons. So 2 chlorine atoms came together, right? They both has taken 1 each. You have to remember, 1 magnesium lost 2 electrons. It gains 2 chlorines has taken 1 chlorine each. Right? So let's go for this one. Formation of magnesium chloride. Right? 1 magnesium atom gives its 2 electrons to 1 each to 2 chlorine atoms. Right? Magnesium is giving, right, 2 electrons which is taken by 2 chlorine atoms. 1 each. That's what here representation. Magnesium is giving 2 electrons. Chlorine has taken 1 electron and this chlorine has taken 1 electron. 1 magnesium, 2 chlorines. That's the logic says. Now, Mg2 plus and 2 chlorine atoms. 2 are unipositive, uninegative. 2 chlorines which are uninegative get combined. Right? So, combined to form neutral magnesium chloride. Hope you are able to understand. Magnesium 2 plus. How many chlorines has come? 2 chlorine. Of course, each chlorine is uninegative. 2 chlorines, 2 uninegative ions. They both, this is cation and this is anion. They both came together because of the opposite charges and electrostatic force of attraction is holding them together to form magnesium chloride, which is neutral. This is how magnesium chloride, a neutral compound, is formed, which is a best example of ionic bond. Hope you understand. In this channel, I have been placing both math and science videos.